Concept 2, finding missing measures in similar figures. So, just like we did in the last video, finding the missing angle of a figure is as simple as finding which two angles correspond, or which angle corresponds to your missing angle. Okay, and sometimes, you know, these shapes, your figures could be, well, they could be turned around, so you might need to figure out which angles correspond. But as soon as you know which ones correspond, you're going to know the value because it's going to be the same as the value in your similar figure. Okay. Finding the missing side length is a little more challenging sometimes. You need to basically set up your proportion, okay, and make sure that you have those corresponding sides. Okay. In a rectangle, it's fairly straightforward because you basically have two side lengths that are the same and two other side lengths that are the same. So I don't really have anything to mix it up with, right? I've got my short end and I've got my long end. Okay, so I can do my let's start with my variable. Okay, so my variable is here, and that I'm going to say I'm going to do the lengths for my larger rectangle. Okay, so I have my short side over my long side, and now I got to do the same thing for that one. Short side over the long side. Okay, and now you can find the cross product, and that will, I mean, basically you're going to isolate x either way. Some people go ahead and multiply everything over, and you would have 10 times x, and then 35 times 3. Okay, but then you're going to end up having to divide by 10 anyway, right? You're going to divide by 10, and that's going to bring it back over here, and you're going to be doing the same thing with more steps than if you had just come back to the start and just multiplied both sides by 35. Right? Multiply both sides by 35, those cancel, and look, I've got 35 times 3 divided by 10. Okay? Remember, this only works if you have your variable in the numerator. Okay? That's the only way you can skip the step of moving the 10 over and then moving the 10 back. All right? So, 35 times 3, that, let's see, should be 3 times 30 would be 90. 3 times 5, 115. So we got 115 over 10 is equal to x. And then we can check this. We can simplify this. All right. Since this is divided by 10, we can just move our decimal over one. All right. And so we've got 11.5 is equal to x. Okay, we can fill that in. 11.5. And we could, you know, look at it to see if that makes sense. Well, if this side is 10, does that say, yeah, that side could be 11.5. Right? So it's always good to check. Although sometimes the figures in your book or on a test might not be as accurate as they would need to be. So trying to just eyeball it will often lead you astray. Okay, the last part of this that we have to look at is this sign right here means similar. Okay, so this figure, this A, B, C, D, E figure is similar to F, G, H, I, J. And what that means is A, this point right here, okay, use this one. This point corresponds to F. So this and this are corresponding points. Their angles are corresponding. Okay? This becomes really important when you're looking at strangely shaped figures that are supposed to be similar, because it might be hard to figure out if I'm looking for this angle to figure out which angle it is in this figure, right? If I know that this angle is, well, it's not 30 degrees, it's going to be like 85 degrees, a little less than 90. Okay, if this is 85 degrees, well, which one of these angles is 85? And what you have to do is you have to go through and say, okay, this is H, so I have F, G, H. H is going to be corresponding with 1, 2, 3, the third angle over here. Okay, so this side, or this angle, is also 85. All right, sometimes that can be more confusing than others. Using the label that tells you that these two figures are similar can be helpful. All right, if it's complicated and it's harder to figure out, use the label.